Good afternoon, and thanks for being here. I'm Gianpietro Lavado from OpenStack, and today I'm going to share with you a true story about us as a company looking how to build an NFV MANO stack based on open source technologies. Let me see if this works. Okay. So why do we even want to do this? First of all, we like the NFV concept. It's very promising. The promise of NFV is to make us more independent on the boxes. No? So we want to deliver that to our customers from the telco space. Second of all, why MANO stack? No? We already have virtualization. We can virtualize network functions already. But the reason of having a management and orchestration stack is to, beyond the Vim, beyond what OpenStack would do, for example, is to bring more automation to a table, to really have agile virtualized services by adding more automation layers and being able to quickly deliver end-to-end virtualized network services, not just VMs and containers. I'm talking about network service lifecycle. And then why open source? Well, that's pretty obvious in this kind of conference, but open source have proved to accelerate innovation, right? It reduces vendor lock-in, for example. So the value is huge. So that's why we at OpenStack wanted to build an open source based NFV MANO stack. But at first, we didn't know which component to use. I mean, we were not looking for something complete. We were looking to contribute to the existing components. So first of all, regarding the Vim, that was the easy part because everybody was already using OpenStack. Even the VMware version, I mean, most of the companies that already were deploying NFV were looking at OpenStack. And of course, OpenStack is cool, right? OpenStack has a truly open community and has a huge interest in the industry. So that's the Vim we picked for our solution. But the upper MANO part was not that obvious. We were looking for a working solution, at least the basics of BNF, Network Services Lifecycle Management, and an active community, right? Because that's what makes the difference in an open source project. And a community to start contributing with, not just use whatever there is there. It's there, but contribute to that community. So at that point, that was last year, there were 4 main projects for providing the management and orchestration part. Just a clarification, this MANO stack that from the NFV ETSI architecture includes the Vim as the MANO, but when I refer to MANO here, and it happens in the industry as well, I'm referring to the upper parts, so beyond the Vim. So comparing these 4, at least for us, it was a matter of, first of all, seeing if they had a working solution, and it was the case in most of them. In OwnApp, for us at least, it was difficult to get started because it's a big stack of components, and they were not ready at that time anyway. So regarding the community activity and the traction they had in the industry, I mean commercial traction, commercial interest, we noticed that obviously OwnApp had a huge activity. And second of all was open source MANO with a pretty large activity, I mean, continuous events and commercial interest and contribution for many companies. It was not the case for OpenBayton and Tucker at that time, at least. Other things I could share about the projects. OpenStack Tucker, we found that it was technically complete, but too tightly integrated to the Beam. So whenever we change something in the Beam, it could break the Tucker client and things like that. I mean, we prefer to have the Mano stack decoupled from the Beam to avoid those kinds of problems. Regarding OpenBayton, it's a technically very strong project. The architecture is very neat. Regarding ONAP, we think it's technically complete because it comes from a production-grade development like eComp, but maybe it's too wide for our use cases, at least. And regarding open source Mano, it has a working solution that technically we had some observations, but it has had a huge leap forward in the latest release, and we heard about the plans at that time. So at the end, that was our decision to go for open source Mano. And in summary, what we got with open source Mano is that it's a stack that just solves the problem, the lifecycle management problem, and not only focusing on matching the ETSI architecture, but really solve the problem of existing networks, integrating with a brownfield, for example. You have different environments, and open source Mano is a tool that can integrate with these different kind of beams and different kind of SDN controllers, and that's one of the things we like about the project. The other thing is that it's lean. Today, you can get started with open source Mano in your laptop. You just, if you have a Linux VM there, you can raise the whole system in Docker containers, and even you can include an OpenStack emulator there, emulated by Docker containers and ContainerNet. So this, we think it's important because it attracts a diverse community. Anyone can get engaged quickly. It's truly open. It reminds us of OpenStack in that sense. And most importantly, it's constantly fed by real use cases from operators. It has a group called Open Source Mano End User Advisory Group, which feeds open source Mano with the priorities that operators want. And at the same time, the project being hosted at ETSI, it fits the standards and the other way around. So it's a nice collaboration happening there. OK, so we got our open source NFV Mano stack. And what we did then was to start validating the stack with other components, maybe integrating with other beams, integrated with as many VNFs as possible. So we participated in the recent ETSI second NFV plug tests this year in January. And it was a success for us. I mean, we could execute at least 80% of the tests successfully. And we are taking the new release to the next edition and to the OpenNFV Plug Fest. That is next week and in the next 2 weeks, these two events. So we got our stack. We can build a solution based on open source Mano and OpenStack. And now let's see how this looks like, how the architectures integrate. OK, this is more or less the architecture of open source Mano. It includes, well, the core components consist of a resource orchestration component that is the one in charge of integrating to the beams to instantiate the resources that are needed. Of course, it has a central orchestrator. It's called the lifecycle manager. It has monitoring and policy management components to handle metrics and alarms and thresholds. It has a BNF and configuration and abstraction model, which is for day 2 operations over the BNFs. So we can configure the BNFs after instantiation at any time. And it has, this is new, a new Kafka messaging bus for efficient asynchronous communications, a new northbound interface, which is aligned with ETSI's Sol 5, and a couple of clients. Just like in OpenStack, we have a CLI and a graphical interface, which is new as well. So most of these components have been updated or are new in release 4. And then, well, it integrates with OpenStack through the northbound interface of OpenStack. So we have the monitoring model talking to the telemetry services, and we have the resource orchestrator talking to the compute, networking, and storage services of OpenStack. So as I told before, most of, or many of these models have been updated or replaced in the newest release. So the new architecture, for example, includes this messaging bus, which is very important to receive more contributions because developers can plug in their new modules or proposals easily in this communication bus. And it's not only compatible with OpenStack, but it can also integrate with other beams because, as you know, there are existing networks with, for example, VMware, the traditional platform called BCD, or we have some network services or some telcos that want to put their network services in a public cloud or part of them, or have at least a possibility to do that. So it integrates with Amazon as well, and also with a bunch of SDN controllers. So let's now talk about the features that we see in the two components, in the two stacks. So OpenStack, we think that it has at least most of the features needed for NFV. So mainly enhanced platform awareness features, service function chaining, and network slicing. So huge pages, management, CPU pinning, and new methodology awareness. Those features that belong to the NFVI can be easily controlled from OpenStack today. And we have seen a lot of enhancements in the upcoming Rockies release. Regarding service function chaining, it also has a very strong support with Neutron. Network slicing, I think, is just starting, but it has at least maybe more than what it's today implemented in the Mano platforms. So we have to get advantage of these network slicing features like role-based access control or QoS. And also, it can control the data plane assignment. So some BNFs using SRIOV, some BNFs using DPDK or OVS plane. So in general, we feel comfortable, and I think you too, with OpenStack for NFV deployments. About open source Mano, it also has very interesting features, and it's going already beyond the basics. So, of course, we can do, with open source Mano, network services main lifecycle management. We can control enhanced platform awareness, so we can pick which BNFs need CPU pinning or SRIOV or whatever enhanced platform awareness feature we want, as long as the beam supports it. We've got also this possibility of sending configurations to a BNF, and for this, we are using UU. There's a possibility as well to integrate with SDN controllers. As I mentioned, before. So I'm sorry, just 1 sec. 5 minutes, you said? But this is a 40-minute. 20 minutes? No, it's 40.
No, it's 40.
It's 40. Until 4:10. Okay, thanks. Oh, you scared me. So data plane assist features to make all the port mappings between the VNFs and the physical underlay network. So this is through the SDN controllers like ONOS or OpenDaylight. We can do metric collections and set alarms and thresholds. So we get an alarm and can, for example, scale in or scale out based on a Vim-based metric. We can, and this is new, we have integrated some tools for some analytics tools for enhancing the performance management and fault management of the platform. And there are also some features coming in the next minor releases, so in the next couple of months maybe, like metrics directly gathered from the VNF, so we can take scaling decisions and other decisions based on these metrics. So these are metrics, not the common metrics from the Vim like CPU or memory utilization, but I don't know, sessions per second or things more related to the function itself. And also to scaling based on Vim and VNF metrics. This will be ready very soon. And for the next major release, which will be release 5, OSM will have also a Kubernetes support, network slicing. We think those are features that are very important for 5G. And I put a link there in the bottom. This is just a post where I'm telling the experience we had at the NFV plug tests. So you can take a look at that later. And there are 2 posts, one from the Vim perspective and the other one from the Mano perspective. So you can get an idea of the event and how this stack performed in those in that event. Okay. Now let's see these guys in action. So what you will see is a preview of the OSM Release 4 because it is going to be launched publicly this week. So we have a new graphical interface, a few fully Dockerized deployment, and integrations with external analytics tools like Grafana or ELK. So let's switch to the demo. Okay, so this is how the new graphical interface looks like. It comes from a project, from the Superfluidity project. An important contribution, of course. So we have the concept of projects. So this is meant to be multi-tenant. And of course, the network services packages, VNF packages, and network services instance. Right now, we have, for example, 5 instances there. And we see here the packages. We can onboard a new package, for example, as easily as dragging and dropping the descriptor, or the package that includes a descriptor and other artifacts. So we have it there. And if we want to instantiate an onboarded network service, we just click on that button, and for example, VNF example, and we select the Vim, which is pre-configured in this case, and we create that. So if we switch to the Vim now, we should be able to see the new instances there. Okay, so there they are, 0 minutes. So it's as easy as that. regarding the Beam accounts, for example, the Beam management, we can create new connections to different Beams. As I told you, OSM has support for OpenStack, VMware BCD, and AWS, and another testing Beam that is called OpenBeam. So depending on the Beam type, you can have extended parameters as well, like these config parameters, but those are brought by the Beam, depending on its type. Okay, so what else we can see here is that, for example, regarding day 2 configuration, we manage this using proxy charms. Proxy charms is a lighter version of the UU charms that run scripts remotely using SSH, for example. So the MANO platform is logging in through SSH to the VNF and running scripts. And for that, I have a pretty basic example. Let me show you. This is how the code for a proxy charm looks like. Actually, it's a template, and it's very simple to modify. And one can put whatever function you want to execute in the VNF using Python for now. So you can do whatever automation script you want to in your VNFs. And these VNFs that are already instantiated here, network services instances, have that capability. So we are including, this is a very basic example again, a say hello script that just says hello to whatever the parameter name was called. So this is just to show you that the MANO platform can actually send something and execute something inside the VNF. So for example, here I will execute the network service primitive. I just put the name of the primitive there, the VNF index of the network service, the name of the parameter, and a name. I will say hello to Benjamin. But we need to see that in action, right? So before that, I need to see the IP address of the VNF, so I can log in and check that it's actually saying hello. So I will access from the MANO platform to the VNF. Okay, I'm inside the VNF. I'm just going to run the action. Okay, set hello. So of course, this is a very basic thing, but you can send whatever script you want at any time of the life cycle of the VNF to modify configurations, to upgrade the version of your VNF or whatever. The other thing I would like to show you is the metric support. So for that, we are integrating with Grafana. This is just an option because actually the monitoring module of OSM is putting the metrics in the Kafka bus. So whatever platform is ready to integrate and read metrics from a Kafka bus can show them in this, just like as Grafana is doing right now. We're using Grafana just as an example, but it could be any other tool that has this kind of support. And actually, this is based in the Prometheus time series database as well. I will show you more about that in a minute. So this is showing the BDU CPU metrics and the BDU memory metrics. We have a couple of VNFs there, or BDUs, that have 100% CPU. And that leads me to showing you how alarms and thresholds work as well. So I have my OpenStack environment here without alarms. And what you can do from open source MANO is use the CLI, and I'll get this opportunity to show you how the CLI works. So you have the OSM command line interface, and it has many commands. So for example, enabling metrics over a BDU or VNF, or scaling, or creating packages, or instantiating packages, or just, for example, listing the network services. There you go. And what I'm going to do is to configure alarms from here. So I have here a script of alarms. I'm going to create a lot of alarms. And these alarms relate to CPU utilization and configure some thresholds and of course, an operation. So they will trigger if the value is less than or greater than the specified threshold. So I'm going to configure the alarms. And what we will see is that these alarms will map to the beam. So this is right now available in CLI only. As always, the features usually start at CLI level, and then they will be mapped to the graphical interface. So right now, the state of the alarms is OK. You will see that this can integrate with another graphical interface, and in this case, we are using the Elasticsearch, Logstash, and Kibana stack, ELK. So we can discover if there is an alarm in there. So let's see if the alarms are triggering. OK, we have some triggers there. So I'm going to show you the, OK. I'm refreshing, and right now you can see there some logs regarding, for example, alarm creation and alarm notifications. But, well, Kibana is a very powerful tool, and you can actually have some filters there. For example, filter on notifications, or you can even build your own dashboard. And for example, here we have a dashboard that is showing the scale-in alarms related to CPU, the scale-out alarms, the scale-in alarms related to memory, and whatever you like. So this is the kind of thing we are looking for to give at OSM community these kind of tools to ease operations. OK, so back to the presentation. A little bit more of detail about how this is working. Regarding how the clients connect to OSM, I told before that we have a new northbound interface. So the OSM CLI and the OSM Lite UI, the new graphical interface, they all talk to the new northbound interface, which is based on ETSI Sol 5. And this sends the orders to the Kafka bus, which in turn can send any order to any of the models existing or new of the OSM system. Regarding the metrics visualization part, the monitoring model, what it's doing is taking the metrics either from any beam, from OpenStack, VMware, or Amazon, which are that supported right now, and they put the metrics in the bus. So as an option, the community is offering this stack of Prometheus plus Grafana to seeing the metrics. But of course, if the community is targeting brownfields, this will remain optional because the operators can choose to plug a different set of tools. Regarding event visualization, is the same philosophy. The alarms are created, and whenever they are triggered, they send these messages to the bus so they can be read from whatever visualization of alarms stack you have there. We have ELK, but you can have yours. And as of release 4, integration can be made through a Kafka bus or through directly sending the logs to a TCP port. OK, so if you are interested in deploying such an open source NFV MANO stack, there are some companies that can help you. Of course, in the Beam part, there are a lot of companies providing distributions of OpenStack. But since Mano is a newer concept, there are less amount of companies providing, at least publicly, a distribution of open source Mano. So we are one of them, and there's Rita as well, and we know that there are 2 or 3 releasing a official of a commercial distribution of open source Mano within this year. No? So that's for your information. Okay, so that's all I wanted to present. Any question? Yes?
What are the other 3 companies which they are?
Honestly, I don't know. Yeah, I don't know. I know there is at least 1 or 2 processes, RFPs of big operators starting and interested in open source Mano. So from that, I've heard that there will be at least 4 companies participating in this
How come
processes.
there any updates coming on the website? How is it going to affect the OSS? Every time there is a change in
Well, the APIs remain pretty stable, but if there's any change to be made, we manage that through plugins. So we have a plugin layer down here, and any modification will have to exist here. So we try to abstract the upper layers from those changes.
Are there plans for in the near future for implementation of BNMG?
Yes, actually there is support, some basic support for SFC. So yeah, I can give you more details later if you want. Yeah, you can control neutron-based SFC right now. I would have to check what is available depending on your use case. Mm-hmm. Yeah.
The open source Mano can be like a centering point for many pods out there to control and monitor and orchestrate at the same time.
I'm not sure if I get your question.
The open source Mano, I mean, what is the capacity towards multiple pods? Can it work with hundreds of pods to read and write and orchestrate?
Yeah. I mean, it's the position it has is, I would say, is pretty agnostic to that. I would say that the main point or the first point of congestion would be the beam before the Mano gets congested with that amount of resources. You can also have a multi-beam approach, and it would be just a matter of resources, or the resources you put available to the platform. Of course, you can scale. Eventually, you would need to scale the Kafka bus and build more parallel instances, but that is distributed, of course. So most components, or all components, scale in an horizontal way, so there will be no problem.
That the horizontal scaling work is done?
It's not in release 4. For now, we have just the Docker containers, so we're working on next release, release 5, to orchestrate the OSM system through Kubernetes, automated scaling.
But it's working now with OpenStack, at least, with the Vim OpenStack. It's fully supported.
Fully supported OpenStack, and these two, VMware and AWS, yes. Any other question?
Is there any alternative to Juju?
Not right now, but we're looking at that. So in the past, there was just this BCA module that is strictly Juju. But now, right now, there is an intermediate module called N2BC that will enable us or any community participant to develop its own module and integrate to that intermediate component so the orchestrator can use it for communicating to VNFs. So, of course, that could happen in the future.
I was just asking, just like
enterprise version, so commercial versions. Yes, well, we at Whitestack, we have one. Yeah, as I was telling before, there are at least 2 vendors that I know of. Of course, I can speak for one of them only. But there are more coming in the future.
And for upgrades and updates,
Mm-hmm.
what upgrades and updates open source MANO can do? Is it only the OpenStack Vim layer? Or
Upgrades and updates of
Vim, OpenStack?
the Vim,
Yeah.
it doesn't handle the Vim system as itself, just the resources that it can instantiate.
Like what? An example for upgrades or updates?
You can, for example, upgrade or update your VNF, but not the Vim. It's not the case. It's not a use case for NFV anyways. Would not be the role of the MANO platform.
That will be done by Vim or OpenStack.
Mm-hmm. Yeah, for OpenStack itself. Well, thank you.